Good afternoon, or morning, or evening, or night, you sentient nerds. Welcome. We've been doing some chemical process analysis videos for a while, and I think it's very important to talk about some study tips. So if you're starting chemical process analysis and you feel like you might need some study tips, this might be right for you. This can also apply to several other applied engineering classes such as fluid mechanics, thermodynamics. If you're a mechanical engineering student, if you're a chemical engineering student, I hope that these help. There's not a lot. There's really only 2 tips, really, in here. So there's not a lot of content, but I think it's the bulk, the character of the content that really matters. Okay, so number one, the number one thing that I would have to stress is to stay motivated. College is its own little monster university. You really have to figure out how to play the psychological mind game of working the system. If it seems tough, it's because they do it for a reason. They want to train you. They don't want some civil engineer to be kind of good at statics and kind of good at building bridges. They want that civil engineer to be a master. For chemical engineering, it can be very dangerous, right? So they want their engineers to be really good at plant safety and plant design. And this class is the fundamentals. So you have to do whatever it takes to get through this mind game, all right? When the going gets tough, you know the saying, all you gotta do is just figure out what you have to do. You have to work hard, you have to study more hours, stay late at night, stay at the library until it closes, stay until la madrugada, just work until you get it done, all right? But at the same time, balance. Work hard, play hard, okay? So if you time manage correctly, there is time for everything. Yes, you have to learn how to make sacrifices, but you can balance out because you want to avoid burnout, okay? If you work hard all the time, unless you're super, super motivated and you're like a robot, you're going to burn out, okay? You're going to have to learn how to effectively manage your time so that you can understand how to solve problems and learn to sleep. Have a good sleep schedule, okay? Remember that university is a huge psychological game, okay? Why are you here in the first place, okay? What is your real motivation? Is it because of mom and dad? They're doctors, they're engineers, they're physicists. Now you gotta be one too? Or is it money? Yes, chemical engineers do tend to make a lot more money than their peers, but that is not always the case, especially if you lead to less motivation and you're not doing what you love. You're doing because of money, you're doing because you have to. What about the science? The science of chemical engineering, learning how chemical engineering is everywhere. Cups of coffee, stain in your t-shirt, sunlight, doors, I don't know. Doors. What I'm trying to say is that thinking about the science of chemical engineering is a good motivation because you can think about the heat transfer of your room. You can think about the fluid mechanics of a cup of water, the separation processes of making a cup of coffee, Just think about that kind of stuff to get you motivated through tough times. The tough gets going. Number 2, 99 problems. You gotta do a ton of problems, honestly. You got so many problems you have to do in order to understand the material. It's about understanding the concepts and applying it to solve the problems because at the end of the day, most likely in an engineering class, you're not going to be asked what's the definition of a batch reactor. You're going to be asked, solve this mass balance, solve this energy balance. Okay? And they can be pretty tough. All you got to do is practice. As cheesy as it sounds, practice makes perfect. Really, that's all that it takes. Easier said than done, yes, don't get me wrong, but you don't have to play this guessing game of, oh, what's going to be on the exam, what's going to be on the exam. If you just practice and practice, it will eventually make sense. Imagine a first grader seeing algebra for the first time. X plus 3 equals 5. Imagine what's going on through their head. X plus 3 equals 5, what does that even mean? But to you, that should be second nature. It's simply just going to be x equals 2. But after practicing, now it becomes second nature. And just like that in chemical engineering, you're going to be facing the exact same thing. What the heck is a mass balance? But through practicing and years of dedication and motivation and hard work, it will make sense. Problems. The homework is there for a reason. Homework is only, what, 10% of the grade, 15%, 20% the most of the grade. It's not to give you that 20%. It's to give you that edge because it will be on the exam. I can't stress this enough. The homework will be literally on the exam. Do you hear me? If you get one thing out of this, the homework will be on the exam. They're literally going to take the exact same, they're going to copy and paste the exact same problem, change two numbers. They're going to change the 5 to a 7 and the 13 to a 3, and that's going to be the exact same problem. I'm afraid to say this, but because, is this cheating for saying this? The homework will be on the exam. The professors themselves say it. The homework will be on the exam. The homework will be on the exam. If you don't do the homework will be on the exam. What else do you want me to tell you? Okay, that's honestly the rest of that's honestly all the tips. This is just a message to my past self when I was taking sophomore year Intro to Chemical Engineering, Chemical Process Analysis. Disclaimer: this is not applicable to everyone. Okay, so keep that in mind. Take this with a grain of salt. I hope this helps you, but it's a little bit controversial. Okay, why? Because first thing, don't compare yourself to others. Everyone else has a different background. Some people already took multivariable calculus. I don't know. People have different backgrounds. People have different knowledge levels. So if someone is getting it while you're struggling, that's okay. As long as you work hard, you'll get it eventually. Okay? Time management is key. Okay? You're going to have your OChem midterm on Friday of week 4, and then you're going to have your math midterm on the Thursday, week 5, and then you're going to have 2 midterms for engineering on the Monday and Wednesday the week after. So don't put all your time into just OChem and math because you're only going to have the weekend to study, which is what you do, and you end up screwing yourself over. So how about you just balance out? Yes, put a lot more time in the beginning because OChem's first, but don't put off CHE to the side because this class, okay? Don't study just the weekend before for the exam, please. Do me that favor. I know you're not going to do it, but come on, dude. A's before B's. Look, I get it. Sophomore year, new apartment. I hate to say it. I get it. You're excited. You're in this whole new world of just talking to people and stuff. But why are you there in the first place? All right, come on, dude. Time management. I mean, you can have fun, yeah. Time management. Work hard, play hard. That's what I just said. But A's before B's. Okay. Not gonna lie, this class is pretty tough. Honestly, I feel like it's basically a crash course of chemical engineering, honestly. You're gonna be doing 3 years of chemical engineering in about 4 months in 2 classes. So, not gonna lie, this class can be pretty tough. And it's extremely tedious because it's a bunch of algebra, and you're not allowed to use computers, and blah blah blah, no MATLAB until junior year, but if you work hard now, it will get better. Much, much better. Don't be stressing. You're going to make it through college as long as you do the work, okay? It will get better. Remember, don't compare yourself. Don't compare yourself to others too much, but it will get better. Like I said, this class is applied to pretty much every other class. Thermo, fluids, heat transfer, mass transfer, separations, process control, even senior design, mass balance, energy balance, mass balance, energy balance. This class is pretty much everywhere. You can't escape it. You can't escape it. So just get through the tough stuff now because it will give you that foundation for the rest of your classes. I have one more tip, actually. I lied. Remember, when in doubt, accumulation equals in minus out, plus generation minus consumption. This equation, I can't stress this enough. Like I said, it's applied to pretty much every class. Mass balance, energy balance, mass balance, momentum balance in fluid mechanics. Mass balance, energy balance. It's a momentum balance. I can't stress this enough. When in doubt, accumulation equals in minus out. In minus out. That's it. And fortunately, in this class, it's accumulation equals in minus out for most systems, and accumulation is 0, so it's really just in equals out. That's it. That's it. In equals out. If this makes no sense to you, we're going to do a ton of this. Don't you worry, child. We're going to be doing a ton of this. Don't get me wrong. Alright? That's it for this video. Good luck and have fun. Yes, engineers do have fun. Contrary to popular belief, it is possible to have fun in engineering. I'm probably going to do some videos on what I'm talking about because, yes, like I said, engineering and science and chemical engineering, the science of engineering is everywhere. You look at a fan. I'm just looking around my room and I saw a fan. There's fluid mechanics and concentration gradients and pressure gradients and physics of how the fan works. And you look at, I don't know, dirt, soil science. I don't know, just everything has so much science behind it. Don't be discouraged, okay? Honestly, I think I'm just gonna go back to this one. The homework will literally be on the exam. That's it.